So this is a tutorial on how to create a lab report using your Google Drive. So right now I'm going to actually get a couple things going. I have two tabs open. The first one is I Googled Mr. Helland Science Teacher, one word. That'll bring me to my website. And I'll go there right now. And I'm going to go to the lab section. And it actually gives me the rubric and an example of a lab report. So I'm going to go to the rubric. And it's going to give me a breakdown of the different sections I want, like grading, name and title, purpose, hypothesis, and what I'm looking for in each section. So first I'll go to my drive and I'm going to create a new Google Doc. First thing I want to do is give it a title. So I'm going to title this one Solar Cooker Lab Report, since it is going to be my Solar Cooker Lab Report. So if I pop over to my rubric, the first thing I see that I need is a name and my name and a title. So I'll put my name, Mr. Helland, and I'll also put that I'm in Chem, and I'm in period 12. Now again, I always like to see that title right dead center, maybe make it the font slightly bigger than the rest. And I'm going to call it Cooking with the Sun. Again, I could just call it Solar Cooker Lab Report, Solar Cooker, but I like a little flair, like you all know. So the first thing I want section was purpose. Oh, my font's too big. I got to make sure I always correct those things. So we'll go back to the 11 font. And I like a nice bold underline for each of my section headings. So, purpose of this lab was to determine, no, we weren't really determining anything, with to build a solar cooker which would heat water better than Mr. Helland's commercial cooker. Sounds about right. We were trying to outdo the one that I had sitting in the class, right? So also in the purpose section, right, I also want you guys to give me the independent variable, the dependent variable, any controlled variables we had in the lab. Now just remember, I'm not actually going to put in what the independent variable is for this lab. It's kind of difficult. Actually, I'm going to give it to you because this one's a little more complex. So, design of the solar cooker. So everybody pretty much came up with their own design ideas. They were all based on the same sound science, hopefully. Then we measured something. We have a data table. That was our dependent variable, the thing we measured. And the controlled variables are things that we kept the same. So from my solar cooker to yours, what were the things that we kept the same the whole time? After purpose, let's go to our rubric. So we have the purpose, independent, and dependent variables. Next we need to come up with a hypothesis. So for our hypothesis, again, bold and underlined. Okay, I believe that my solar cooker would be better than Mr. Helland's because... Now tell me why. What did you do? What functions, what properties did you put into your solar cooker that made yours so much better than mine? So let me know that. Put that in. The next section were the materials. So again, bold, underline, materials. Now I'm going to list them here just because some people may have missed class and so forth. But you were given cardboard. You were given tape, plastic wrap, foil. That's actually aluminum foil, right? Aluminum foil. Scissors, a ruler, glue, stapler, black paper. Eventually we all got a small plastic cup. and I also use a graduated cylinder. So at this point we can see we're kind of moving along here. We got through several sections already and it's only been a couple minutes. Next thing we're going to do is a procedure. So this is where you guys are going to be very specific to what you did. Now there is one section at the end which I generated for you and I told you this is going to be the way you're actually going to test your solar cooker. But this is, again, step by step what you did. How you built your solar cooker. Did you cut sizes, tape, glue? What did you do? Then finally, when you got near the end, I'm going to actually give you the testing steps. So what we did was we poured 40 milliliters of water into a small cup and recorded the temperature. We placed a small cup in our solar cooker and let it sit. Now we're going to say we let it sit. After 20 minutes, record the temperature of the water and solar cooker. After 40 minutes, we recorded temperature of the water in the solar cooker. And then finally, we ended up a little short of an hour, so we did after 55 minutes record temperature of the water in the solar cooker. Now again, I could have worded that differently. I could put every 20 minutes after placing the water in the solar cooker, record the temperature. Just depends how you want to word it. So when you're done with your procedure, the next section is going to be our results. So again, usually in the results we want to start off with a data table. And that's going to be the temperature of water in a solar cooker. In the solar cooker. So again, if we want to put a table and we go insert a table, and we need to have it 2 across, right, for time and temperature. We actually need to have it 5 down. And I don't like that it's so wide, it just looks really obtrusive that way. So I'll click over here. I want to get into this corner so I can make it look nice. Come on, give me the corner, give me the corner. No. Let's do it the other way. Take and table properties, column width, and let's cut it down to 1.5 inches. Let's see if that works for us. This one too. Table properties, column width, do the same thing, 1.5 inches. Yes, I like that much better. Let's go back 1 so we get all on 1. So this will be the time in minutes. And this one will be the temperature. And we need to superscript a little degree. And I will unsuperscript back to capital C. And I'll put in some data. This is actually the data I got from one of my classes. It varied from class to class because the sun was at different spots. So it started at 26 degrees, went to 37, then to 48, and eventually up to 52 degrees. Again, you know me, I'm a stickler for the way I like things to look, so I'm going to center all that data. And I'm going to get out of this data table. And what's the next thing I always like to see, guys? A nice graph. And that'll pretty much show me the same thing. Water in a solar cooker. Now how am I going to create this graph? What I can do is I'll highlight all my data and copy it. Go back to my drive. I've showed you this before, guys. Create a new Google Sheets. I'll then paste my data in. Highlight all my relevant data. Insert a chart. And I think a nice pie chart. Why is it showing two sets of data? Because it's stupid. We just want a single pie chart. Why is it giving me time and temp? It's being ridiculous. Scatter, no. Line, no. Should be a bar or column graph. Use A as labels. No, what is this? I hate it when they don't want to just work nice. It's supposed to work nice. Let's call this solar cooker data. Let's try this again. X and a Y. Insert a chart. Let's insert it and then we'll fix it. This actually is a nice one because it shows the change in temperature increase. But I don't like the fact that it hasn't labeled the axes. I'd like to just keep it. I got this stupid thing on the wrong side anyway. I'm going to insert it and I'm going to hopefully be able to modify all my data. rid of that. Let's see what else we can do. I'm trying to get all the series sorted right. I don't want that. Oh, this thing is not as amenable as I need to see. I don't like that this. Alright, so this is not the graph I want. I'm going to figure out how to fix it and I'll talk to you guys about it. But for now, I'm just going to copy the chart. And I'm going to put it in my solar cooker lab report. Like I say, I definitely don't like this as much as Excel. Edit, paste it in. Now I have my graph. Now I want to discuss my data. So looking at table and graph. Solar cooker definitely demonstrated the ability to heat water. My initial water, or my water, was initially at 26 degrees Celsius, but within 1 hour was over 50 degrees Celsius. I got a couple quick sections here, right guys? Conclusion and limitations. And let me underline all that. Alright, so again, on this part you would say I conclude the data did or did not support my hypothesis. So from class to class you have to decide, was your data better than mine? Did your solar cooker work better than mine? And just explain, no, Mr. Helland's commercial one was better, or yes, no, mine actually was better and he did the water more, and explain what your data. Limitations on this lab. So what things could we not have controlled that could have affected our results? Well, I noticed in my early classes that the sun at a really sharp angle on the horizon did not really work well with my solar cooker, the store-bought one. It is much more efficient and useful when the sun is up overhead. So again, a limitation is when you build your solar cooker for a certain usage, like that one is built for, the sun can really affect it. I know other people, the wind was an issue, pushing theirs over, the tape was giving way, so there's a lot of things that really limited to how well we could have done on this thing. But when we talk about limitations, we want to talk about things that we really couldn't control. So I would say the sun's location when we actually tested it, and the wind could have been a factor as well. So guys, that's a quick, easy little tutorial on how to write a lab report. Again, once you were done, you would want to share it with me, so you'd go to share, and you guys would share it to Gabriel.Helland@nhps.net. and then you would just send it. And that would allow me to look at it, make any modifications I want it to on it. And you'll see it, actually, we'll see it shared with me now. If I went to my Google Drive and looked at shared with me, I guess it doesn't show mine shared with me. But, alright, that's it. I'm going to end there. Try to get your lab reports done today if you can, which today should be Thursday or Friday. And that'll be it. Shut this down and